The focus of this video is on triangle congruence theorems. And to supplement that, or to kind of get us thinking about it, there's a GeoGebra that we had in class today that would help you kind of figure out or see what we're trying to get you to see. So I have a few tasks here, and when something works, we're going to put it in the work side, and when something does not work, we're going to put it in the does not work. And you could just follow along. You don't really need to write that yet, and then we'll formalize those notes. So essentially, we're trying to figure out how much information do we need for us to get the exact same triangle. So what I'm going to try to do is to use information and see if I can get a different triangle other than the one that's shown. So based on this information, I have a triangle here with these three side lengths, 3, 5, and 7. And I'm going to try to take those same three side lengths and make a different triangle. So I'm going to kind of move this around, which isn't really working, and move this one. And it's looking like I'm not going to be that successful. And what that means is that when I have three side lengths of a triangle, if I have one and I'm trying to see if there's another one that is congruent, if I have the three side lengths, this would only create a congruent triangle. There's no other triangle I can create. So I would say this works. If I have three sides, I can only make one triangle. There's nothing else I can make other than this one. Okay, and that's if I have side, side, side. Three sides worked. So let's try another one. What if I have three angles? Can I make a different triangle? So right now I have two of the same, but if I keep these angles the same and I move this, I still have a 30-degree angle here and here. I still have a 100-degree and a 50-degree, but notice my side lengths are much different. I can also make this really tiny. Can't see that though. The angles are all the same, but notice my side lengths are not the same. So it looks like I can break this idea of congruence, right? If I have three angles, so angle, angle, angle did not work. Just knowing the angles does not give me a congruent triangle. It can be a lot bigger, it can be a lot smaller, so does not work. Let's try, what if I have a side, an angle, and a side? Now, it's really important where that angle is. So notice that you have a side, and then the angle is between the two sides that we have. So we've got the green side, then we have the purple angle, and then the red side. The question is, can I make another triangle with whatever's left? So with those standing the same, the only triangle I can make is the exact one I've been given. Like there's nothing else I can do. I have no other sides to manipulate. So I would say when we have a side or an angle sandwiched between two sides, we would say this creates congruent angles or congruent triangles. This works. Side angle side is one that we're going to consider. Okay, so what if we had HL? Oops, sorry, HL. HL is a special one because it's about right triangles, okay? And HL means that we have a hypotenuse right there, that 10, and we have a leg, which is one of the other sides. Doesn't matter which one. So if I have a 90-degree angle and I have the leg and the hypotenuse, can I make a different triangle? Well, if I try to come here or nope, it looks like I can only make the exact one that's on the page. So HL would also be considered a one that works, and this is for rights only right triangles. Okay, we have a few left. So let's try side, side, angle. Notice what it spells backwards, might be something to think about. Okay, so if I have a side, and then an angle, right? So notice that order matters, side. So the angle before was in between, but this one is after. So side, side, angle. Can I get a different triangle? Well, here's the exact one, and here's one that people don't kind of think about, but I could swing this inside and get a completely different triangle. And because I can get more than one triangle and a triangle that is different than the original, this is said to not work, okay? That is said to not work. So side, side, angle, not a congruency theorem. I think we have two left, I think. So angle, side, angle. So notice that we have it, that order matters. So angle, and then a side is sandwiched between another angle. Okay, so if we do that, we then, let's see here, how can I can't move anything else. The only triangle I can make is the one that is made already. So this one definitely works. Angle, side, angle is definitely on our congruence or our work side. There's no other triangle that even is possible. And then the last one is angle, angle, side. So we've got an angle here, and then a side. So if I move this angle, can I make, it looks like with that side length, I can only really make this triangle, because if I'm using something smaller or bigger, it's no longer that same side length. So I think this one works. Angle, angle, side. Okay, so this is kind of the basis for what we're going to kind of use as we continue. So when we start looking at triangles, if we have any information in this side, we're going to say we can prove the triangle is congruent. And if we have anything on this side, we're going to say we don't have enough information to prove that they're congruent because of what we just saw. Like, you can create other triangles with that information. There's no reason to think that they're congruent. So let's be a little bit more formal with our notes, okay? Knowing now what works and what doesn't. So you should have this note sheet, in front of you. And I want to go through and just formalize what this means, okay? And how it would be marked. So and this is in no particular order, okay? So the first triangle theorem that we would say is side, side, side. And how that would be marked is that you would have 3 side lengths marked congruent. So here, here, and here. So if you see those tally marks through your sides, you now know that you have congruent sides. Some people really like to highlight their congruent sides to help them kind of visualize it. That's okay too. You do what you need to do so that this feels and makes sense to you, okay? The second one, I want to do one more thing here. Just make sure you understand what this means. So this is side, side, side. The second theorem is side, angle, side. And this starts to get complicated because of where you start kind of moving around. So I'm first going to say what this means. Side, angle, side. Okay. So I'm going to pick 2 sides first. So I'm going to pick this one and this one. It doesn't really matter. And the angle that's in between those 2 sides is what's going to be marked. So I'm going to mark this angle right here. Okay. Can't be any of the other angles. So if I'm marking this with highlighters, it might be this side, and this one, and this one. And I'm not going to really mark the angle. But when you're trying to look at a triangle to see, are these congruent, or can I determine this, you always kind of want to start where there's an angle inside that's not marked. So you see how this side is not marked and this angle isn't marked. When you kind of move around your triangle, you want to start here. And then I usually tell students, write an S, and then there's a marking for an A, and then there's a marking for an S. It'll help you with this order because we're using all the same letters. So the order is really going to be important. So kind of your next or your last activity today is looking at, how can you prove these congruent? That would be one that I think you could be thinking about. Find a side and an angle that's not marked and move around the triangle that way. Okay. The next one that we saw was HL, and this, remember, is for rights only. And this stands for hypotenuse leg. And so first I'm going to mark the right angle in on this, okay? So I have a right angle that has to happen, and then I have the hypotenuse that's congruent, and I have one leg. I'm going to mark this one. Doesn't exactly matter which one it is. So, oops. Didn't mean it. So that would mean that this is congruent to this, and this is congruent to this. Okay. Again, if you, this is the only one that can get away with 2 markings as long as you have a right angle. And this one's tricky because it looks like it wouldn't be proven congruent, because if you start where there's a side and angle not marked, that would be here. And if I moved my way around, it would look like this, rut-row, right? Not good. And so you would maybe think this can't be a congruency theorem, but it is, because this is a right angle, not a congruency mark, a right angle. Okay, so that's what takes this away and just makes it a 2 congruency, just 2 marks that would make that work. All right, a few more. So let's do the next one we saw, which was angle, side, angle. Okay, so I'm gonna pick two angles to start. So I'm gonna pick this one. And then remember, the side has to be in between those angles. So the only side that's between those angles is there. So here. And if I was marking this, I would just mark this side here, and the two angles are marked, differently if I wanted to mark them. So maybe I could color this one yellow, and I could color this one green. Okay. Again, if you started where there's no side and angle marking, you could start here or you could start below, but no matter what, you'd hit an angle. Oops, that is not right. You'd hit an angle, and then a side, and then an angle. You can kind of see that order. Can't really stress that enough, how important that order is. Last of the congruency theorems is AAS, which is angle, angle, side. Okay, so again, I'm going to start with marking two angles. I'm going to switch them up this time. I'm going to do this one and this one. And so the side has to be after both angles. So I'm going to go ahead and put it here. Okay, so I have the congruency side here, and then I have an equal angle here and here, and an equal angle here and here. Okay, so I want to make sure that when I go through this, I start where there's a side and angle, no marking. So right there, there's a side and angle, no marking. And then I would hit an angle, and then a side. If you're like, what if I went the other way? You could have, because this theorem still works. Side, angle, angle is the same thing as angle, angle, side. Forward or backward, doesn't matter. Okay, and I would accept forward, both of them. It doesn't matter. Okay, so those are all the theorems that if we have that information, we can honestly say and accurately say these triangles are congruent. Let's go through the two that will not give you that information. So if you ever have all of the angles, so angle, angle, angle. So if that's what's marked here to here, here to here, if I was given this, I would say they are not congruent because there's nothing tying them. It could be bigger. One of them could be bigger or smaller than the other, and that's going to be a problem. So not congruent if I see something that's all about angles. The other thing, remember, is this theorem, side, side, angle. And again, so if I have two sides, I'm just going to mark these two, and the angle right after would be this one. If I were given that information, remember that there are two different triangles that can be created. And if you continue on in math, you actually investigate what those two triangles are in pre-cal. That's a pre-calculus standard. But it's because this side swings like a doorway, and it could come in here and be kind of a smaller triangle over here as well. So because that swings back and forth, this creates multiple triangles, which therefore means we can't prove that it's congruent. So this is also a not congruent if you had this order of information. The only thing right now, like the only markings you're allowed to add, so, and I think that's important to mention. So you're going to be looking at pictures with markings already on them as of right now. And the only things that you can add are two properties, okay? Two things that we've discussed before, but we haven't really, well, vertical angles we've used a lot. So remember, vertical angles are created when you have this cross pattern of lines, and they create equal angles on opposite sides, those X pattern angles. So if you see an X pattern angle across from the X, we can mark this. This is a marking that I can add right here and here. I have equal angles across from the X, so I can mark that. That is a marking I can add. Another marking you can add is if they're sharing a side. So in this case, I can see that this side length is in triangle 1 and in triangle 2. So I can add that side. I can add like a congruency mark and say those are going to be congruent to each other. So MP in triangle 1 is going to be congruent to PM in triangle 2. They are the same. So that's a marking I can add. But every other marking you can't add. Okay, if you do, you're just assuming, and assuming is not great. That's not what we're trying to do. We're trying to use the facts and the markings to prove that two things are the same. So again, vertical angles can be added and a side that's being shared can be added, and nothing yet. We'll add to this as we continue through the standard on what you can add to your picture. So for the rest of the time, you're going to try to identify if given triangles are congruent or not based on the markings that are given. Good luck. I hope use your notes if you need help.